So this question is question 22 from our review, and the question reads, how many milliliters of acetic acid must be mixed with 1.518 liters of water to form a 4/15 acetic acid solution? So the first thing that we want to figure out, or just let's pull out the information that we know that we have. So the first thing that we have here, oops, sorry, that shouldn't be moving. The first thing that we have here is the 4/15, okay? And that is a ratio, and that is your strength. So remember that strength can be in a form of a percent, a fraction, a ratio, a decimal even, all the same thing, saying the same, just different ways of saying the same thing. So that's strength here. We're just going to pull that out, but you can't use it as a ratio. So we're going to switch it to a fraction. So that would be 4 mils over 15 mils. But when you're dealing with mils over mils, it is a good idea if you get confused to write, well, exactly like what is what. So your solution is always going to be your denominator. And remember that your solution is your solute, so that's the chemical that you are using. So in this case it is acetic acid, pure acetic acid, plus water. Okay, and we are told exactly, well, how much water that is, and we're going to use that as part of the problem. So for right now we're going to keep that as our strength. And I'm just going to write that down here because it will help us with our next line. Now, the key to the next part of the problem is what the wording of the question says. So it says, how many milliliters of acetic acid must be mixed with 1.518 liters of water to form this solution, this 4/15? So we are going to be using that formula of strength is equal to solute over solution. So we already have put the strength up here. We don't know for solute. This is a mystery, okay, because it's asking specifically, well, how many mils of that would be mixed. So for right now, we're going to leave that as X, okay, or you could say solute. It's totally up to you. And so for here, now we've got to figure out what we're going to write in the solution. So it's telling us here that we're adding 1.518 liters. So remember again that we're working in mils, so the first thing that we would need to do is convert that to its milliliter equivalent, which is just multiplying by 1,000, so you get 1,518 mils. So that is going to go in the denominator as part of the solution, but it is not the only thing that needs to be there, because remember that your solution is both your solute and your water, and that 1,518 mils is only the water. So X, that we're still solving for, will be in that denominator as well. And I know we've done these problems in the first math semester that we had. So now, and keep in mind that this would be in brackets, okay? So we can actually cross multiply in order to get X, isolate X all by itself. So I'm going to move to a new slide. And so now what I'm going to do, let me just rewrite what we had here. So we had 4 mils of solute over 15 mils solution. That's the ideal. That's where we want to get. We don't know exactly how much that is, but we know, so that's the solute, that's pure acetic acid. We don't know how much we're adding, but we know we're going to add that with the 1,518 mils of water. So now we're simply going to cross multiply, and that will give us 4 mils multiplied by X, 18 mils, is equal to X multiplied by 15, okay? You can only cross multiply when you have a fraction equaling another fraction, so please keep that in mind. So if we expand and break open that bracket, you're going to have 4x plus, if you multiply 4 by 1,518, you should get an answer of 6,072. And then x multiplied by 15 will give you 15x. I'm going to move my x's to the right side of the equation. You could move 15x over and move over your 6,072. You're going to have negatives divided by negatives. You should still get a positive answer. It's totally up to you. The idea here is you want to isolate for x. So 6,072 is equal to 11x. Going to isolate for x. So x, when we divide 6,072 by 11, we get 552 mils. And that would be your answer for your solute. Okay? So the answer here would be you would add 552 mils of pure acetic acid to the 1.518 liters of water to get a 4/15 ratio or strength. So I hope this helps. It's a good idea to practice and really understand why is it that the x is both in the numerator and denominator, and it comes down to the definition of what a solution is. It's both your solute and your solvent. In this case, the solvent is the water, but our denominator is always the solution, so that's why x is in the denominator. I hope this helps.